Alrighty, in this video we're going to be looking at graphing radicals, more specifically radicals of the form y equals a square root of x minus h plus k, as you can see here on the screen in front of me. As it currently stands, I've got just the generic y equals the square root of x. Right, I'll put it again, y equals the square root of x. It's a purple now, click it off, it goes to blue. This is exactly what I've got at the very top. And that's because at the moment I have h equals 0, k equals 0, and a equals 1. Now I just want you to identify that the following points are on this graph. We have 0, 0, because of course the square root of 0 is 0. We have 1, 1, because the square root of 1 is 1. We have 4, 2, because the square root of 4 is 2. And 9, 3, because the square root of 9 is 3, and so on. We could keep doing it for all the square numbers. What we need to do though is be able to manipulate those points given any values for a, h, and k. So at this point, if I start changing the k variable, which is going to shift my graph up and down, right, the points aren't following just because of the way I've set them up. But there is something we can do, right? We can say, okay, well, actually, before I manipulate k, which I will shortly, let's have a look at a, what happens. As I make a bigger and bigger and bigger, the whole thing is dilating from the x-axis and it's becoming much, much taller before flattening out. So what I'm going to have to do first is recognize that in this scenario here, the k values, the x values aren't actually changing, right? As I change this a value, my x values, well, x equals 1 is still going to be on there. It's the y value that's changing. So what I'm going to do is I'm going to go to my points here down below that I've labeled, and on all of the y values, I'm going to multiply them by a, because that's really what's going to be happening here. So 0a, then I've got 1a, 2a, and I have 3a. And so now as I change the a variable, the y variable is being scaled appropriately. So as I make this bigger and bigger and bigger, you can see all the points are staying on my function. Even if I get negative, the points are still staying on the function. So that's great. I'm going to go back to a equals 1 though. The next thing, if we move h, which is going to shift my function left and right, obviously the points aren't staying on there, but the y values are. Right, so all of those y values are staying on my function because my functions are not going up and down. So to change this, all I'm going to be doing for all the x values in these points is plussing h. So plus h here, 1 plus h, 4 plus h, 9 plus h. So now, if I start shifting my h variable, all of those points are staying with it because the x value of all those points is with respect to whatever h ends up being. I'm going to put it back at 0 so we have our original function. And finally, the k value is going to shift it up and down, which as you can see is not changing my points at all. So I'm going to have for my y value, because that's what's changing there when you change k, is I'm going to be plussing k on the end of all of these y values. Plus k, and finally plus k. And now when I change my k value, all of those y values are changing in accordance. So now if I change these three values to really anything, all of these points are going to be manipulated in the exact same way, and I'm going to be able to sketch my graph. Now why am I showing you this interrelation? Well, first of all, it's important for you to know how does a radical operate, what does it look like for various values of a, h, and k, but also I'm showing you this because this is how I graph them, right? If I'm solving a problem and it says graph some radical with these coefficients or these variables within it, all I'm going to be doing is thinking about those original points. Let me bring them back up because they're easy to remember as well. When h and k are 0 and a is 1, we have the points, I think about 4 points. We've got 0, 0, 1, 1, 4, 2, and 9, 3. I'm going to be just translating those points based on these terms down here, right? Black, red, blue, and green, these 4 points are being manipulated. So the x variable is going to be just plus or minus whatever h is. The y point, I suppose, the y coordinate, is going to be changing with respect to a first, and then k after. So let's jump into an example and I'll show you specifically what I mean and my method for sketching radicals. So if I jump across here to notability, I have the question sketch y equals 2 root x plus 2 minus 3. So first thing I'm going to do is annotate this guy. This is going to be y times 2, right? So that a variable, remember, I'm multiplying the y coordinate by it first. Then I'm going to be looking at this plus 2 here. I think typically I do it with orange to keep it consistent. This means it's going to be shifting 2 units to the left, okay? Because in my original function over on Desmos, you can see the generic one, it's x minus h at the top, okay? X minus h shifts it. So if I increase h when it's minus h, it goes right. If I think that looks left on the webcam, it goes right. As I shift it more and more negative, it goes left, okay? So it's kind of the reverse of what it normally would be. So when I've got plus 2, it means it's going left 2 units. And k doesn't change though, it's not as tricky. Minus 3 just means it's going down 3 units, or the y value is getting, we're going to subtract 3 from the y value. So what I'm going to do is look at those 4 points. I've got the point 0, 0. I've got the point 1, 1, 4, 2, and 9, 3. Okay, so first I'm going to multiply all the y values by that red times 2. So this time this is going to turn into 0, and then, well, that's going to stay 0. All the x values are going to stay the same for this first step. The y value, 0 times 2 is still 0, so that one hasn't changed. 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6. So they're my new points after I've changed the scaling, okay, or the dilation factor. That's in red there. Next, we're going to shift it 2 units left, which is going to be a change in the x variable. So all of these y variables are going to stay the same this time, but it's going to be the x variable that's changing. Okay, so in the first one, 0 minus 2, because we're shifting it left, 0 minus 2 is negative 2. We've got 1 minus 2 is minus 1. We've got 4 minus 2 is 2. And we have 9 minus 2 is 7. Okay, and that there is the yellow change. This is my horizontal shift, or translation if you'd like. And finally we have our blue one here, which is going to be shifting or translating the y value. So all of these new x values are the same. 2 and 7. And the corresponding y value is going to be down 3, or minus 3. So 0 minus 3 is negative 3. 2 minus 3 is minus 1. 4 minus 3 is 1. And 6 minus 3 is 3. And so after those blue translations, which is my y translation in this example, I have 4 points which have first been dilated from the x-axis, so the y value gets dilated. Then they've been shifted or translated through the x-axis, translated through the y-axis, and these are my 4 points that I'm going to plot and then sketch. So down below, I'm just going to evaluate, like have a look at them for a second here. So my x values, my x coordinates goes from negative 2 all the way up to 7. So that I'm just going to keep that in mind on my x-axis. My y-axis is going to go from negative 3 to positive 3. So it should be symmetrical up and down, much longer on the positive x-axis. So I'm going to go from, let's say that's going to be, that can be the middle, like this, so that's y, and then x goes from negative 2 to 7, so probably something like that, x. I'm going to go, that can be 2, that can be 3, that can be 1, minus 1, minus 2, minus 3, and I'm not going to put all of the axes ticks on here for the x values, there's too many, so I'm going to go negative 1, negative 2, and I'm going to go, what have we got? We've got a 2 and a 7, so that's about 2 there. And of course you would measure this out if you were doing it properly. That's 4, 6, let's say 7 there. Okay, so let's plot these points. The first one is -2, -3, which is down here, approximately there. That's my starting point, because I'll go back to Desmos in a minute, but you'll notice that as the whole thing shifts around, that initial coordinate 0, 0 is always the base of the function when you graph it. So that's going to be my starting point. Then I'm moving to -1, -1, which is about there. Then I've got 2, 1, which is there, and then 7, 3, which is about there. And it will continue going, right? If you wanted a more detailed one, you could translate the point 16, 4, or 25, 5, or 36, 6, and so on, if you wanted more. But this should be good enough for me, because I know it's going to shoot off in the direction to the right on my function, and it's going to look something like that. Okay, I didn't perfectly go through my points. I'll give it one more go because the perfectionist in me is coming out. There we go. Now notice that there's also not an asymptote here. Okay, these x values, -2 is the smallest x value I possibly can have. If my x value gets any smaller than -2, right? So if this value here gets smaller than -2, say -3, this whole radical is going to be a negative. And I can't have that unless I'm in the complex number world, which I'm not in this example. If I'm not in the complex number world, I can't have a negative radical. And so I literally cannot go past -2. -2 would give me -2 plus 2, which is 0. Square root of 0 I can do, that's 0. But even -2.000001 suddenly gets me a negative radical, and I can't have that, okay? So that's the starting point here. We can't go past this point, so it's not going to continue like that, and it's also not an asymptote because it actually does get to -2, it just can't go any further. So -2 is inclusive, anything else is not. So if we wanted as well, this is not part of the question, but it's worth doing. The domain for this function is going to be from -2, that's inclusive, because it can be -2, all the way up to infinity. Okay, obviously a parentheses there because infinity is not a number, it's a concept. And my range, okay, my range, that -3 does get included also. So -3 there for the bottom of the range, all the way up to positive infinity. Because despite looking like it's going to, keep going and then stop, it actually doesn't. If you give a big enough x value, the y value will approach infinity in this case. Okay, so there we go. That's sketching the parabola. The last, sorry, not the parabola, the radical here. The last thing I wanted to show was something I referred to earlier, which is going back to Desmos. Watch this point here, 0, 0, that initial point. No matter what I change A, H, and K to, okay, I'm going to zoom right out. We can change it heaps. We can go negative. We can flip it over. That's always that base point. That black point there, which was 0, 0, is always going to be the base of your radical. So just keep that in mind as you're sketching. That's going to be the final point there, of the starting point, and then you've got an arrow indicating that that guy is going to go on forever. So hopefully this video helped you. I should have probably said this at the start, but I'll put that Desmos file so you can play around with it yourself in the link to the description and on eLearn. Otherwise you can create your own. Hope this video helped.